Okay, so here's the thing about qualifying,
Oh,
about
wait.
allowing somebody
Wait.
to do an open
Yeah. Okay.
in an OCaml, for example. That's the typical thing that you do for convenience, but you
Yes.
forget about it,
But
and then you
but
have to make a
here's
refactoring, undoing it later.
but here's the thing. Nothing prevents us from doing scope-based opens. Like in OCaml, for example, you can do it
Ah,
with the
okay.
Latin, right?
They also introduced that for Haskell in with the qualified do
Not
notation.
only that, but also this year, for example, like imagine you have complex numbers, right? So you can do uh,
We can only allow opens in the scope of a predicate
so
definition.
this, for example, here is also valid, I think. I think you need a dot in OCaml, not sure. Something like that.
Ah, I see what
So
you mean.
you see the plus, which is the function
Uh
you're
huh.
invoking,
Makes
is the
sense.
complex plus, not just the normal plus, you see?
That makes sense. That
So
makes sense.
that's also like so long as we can delimit the boundaries to localize the search, like the namespacing, I think it's okay.
Yeah. Anyway, but we're gonna introduce opens. If we're gonna introduce them, I think that I think allowing opens in the body of predicate declarations is fine. What you also did is fine, but that's definitely not for V0 for now. For now, everything's gonna
Oh,
be
for just
qualified.
qualify everything, yeah, I agree.
Um, as an interesting data point, um, Zig used to have a construct where you can do like using namespace, and that splices namespace into the current one. But they actually
Wait,
removed it recently.
Yeah, Jai
really?
also has that. I think I also showed you that you can do a if you're receiving an argument of a pointer of a struct or a struct in Jai and you use the keyword using, it allows you to have scope access to the fields of the struct automatically. You don't have to like put the prefix of the struct and then dot.
Um, it's kind of similar, kind of not, because Zig's using namespace is only for types, like actual types, not struct instances.
Nah, okay, so that's a little bit different, but I think the spirit is kind of similar.
It's yeah, no, it's actually closer to open in OCaml
Yeah,
or ML in general, I guess.
yeah. Why did they remove it though in Zig?
Yeah, I was going to ask that.
Because it simplifies name resolution.
No
Not
shit.
only name resolution, but
Oh,
also
well.
it also simplifies any tooling that has to deal with names. Actually,
I don't know
like
if I
it's easier
like that
to.
justification, man.
That
They are
sounds.
literally saying and we're not talking about usefulness and trade-offs. We're talking about easiness of implementation.
It's not really just about ease of implementation. It's also about ease of specification.
Wait, does Zig have a full like ML style
They
specification?
they want to have a spec before 1.0. Yes.
Oh,
Okay, so that's better than Rust already.
okay.
I'm
So
saying
that's
this and
okay.
there'll be a
That
thousand
is
people my
okay.
comments,
That
don't worry.
is a more okay reason then.
Yeah, I can accept that. By the way, I discovered that normal, like standard ML, doesn't have row polymorphism.
That sounds mildly annoying.
That is interesting to say the least. SML sharp, which is a extension of SML does, but SML like normal SML doesn't. That's very weird.
Yeah. Anyway, so let's go. Let's freaking go. So the first thing we gotta do is to double check our representation of the environment, right? That was the last point of discussion. We didn't record that because it was more like a refactoring session mostly, but we started doing. It's there, 48. I already seen it.
48 here,
Uh,
right?
but actually, this is the initialization, not the type definition. You should go up a little bit more. Now there we go. Yeah. So are we keeping these data structures for representing our environments? Because we decided that we're gonna do the conclusion from last time was we're gonna make a file a module because we want to allow you to not have to create creative names along the way and allow you to actually have name conflicts under the umbrella of a module, including a file. But you will be able to change that in the future if you so want to.
Right, because you don't want files to interfere with each other normally, right? Um, so
Is there a
for,
situation where you do want them to interfere?
I mean, sometimes you want to splice a file into another or just concatenate files, right? If you're doing something fancy with
Yeah, if you like,
metaprogramming.
yeah, the example that I gave, for example, last time, you have a list module that implements list operations, but I want to extend your library with more list operations. I want the names to conflict then.
Right, makes sense. So you want to merge two different modules, right?
Yeah,
With
but
the
they are in two separate files or even two separate repos, right? So I want to be able to do that, but okay. And here's the thing: we want to be able to do that, even though we all agreed that file as an abstraction is not the same as a module abstraction. That was the entire point, right? We wanted to maybe make the default conflicting to explicitly tell the users that hey, this language makes explicit effort to not to say that files are not modules. But the convenience argument won anyway. That maybe you do not want to have to care about creative names along the way.
It's not even convenience, it's accident avoidance, actually.
Yeah, I think it's the principle of locality, right? That's what we were talking about.
Yeah.
Yeah, okay, anyway, so the local modules definition, I remember Marinho being pretty happy about it because this is holding a compiler, which is wild, but okay.
I mean, if you're going to compile a module, at the end of the compilation process for that module, you should have, hopefully, um, all the definitions, right, of that module
Yeah,
in the compiler state.
yeah. And then we have the local signatures. That's the one that you were not too sure about it. Are you more sure today about it?
Uh, I'm thinking maybe actually we should probably deviate from OCaml here in ML because you have separate namespaces for modules and signatures, right, in
Yeah.
ML.
Well, I believe that's the case. Mageta, can you tell us?
well, from memory, I think SML doesn't make the distinction. There are two different objects, so you can name them the same. I think I might be wrong there,
Okay.
but yeah, I think that is kind of silly.
Yeah, because it's kind of confusing to have the same name mean two different things depending on where it appears, right?
Yeah,
Yeah.
that's very not what I like. That's true.
And by the
So,
context, you should already be able to infer which is which. So I find that situation very strange.
No, no, no. But
yeah,
that argument is in favor of allowing them to be the same name, right?
Uh,
Because you're saying that the context is usually enough
yes.
that if the
So,
name conflicts, you can still deduce it.
but that doesn't mean, well, on the use, right?
Yeah,
Not on the definitions. That's what I'm saying.
yeah. But I do believe we should not do that because I like the ability to like grabbing becomes easier. I like languages that are grabbable. So you go to the code base, you see a name, and you want to know more about that name, and you just grab it. If we allow the same name to be used for two or more different things, grabbing becomes worse because now you don't know exactly yet. Okay, my use case, what would this be? Would it be a module? Would it be a signature?
Here's another thing to consider as well, which is one is a derivative of the other, right? So the signature should be derivable out of the implementation.
yes, in fact, we will need to do that because, like, it's one thing to have, like, you don't have to specify a signature for the module up front necessarily, right?
Yeah.
Hmm.
So we're gonna need to derive the signature from the implementation regardless, and then if the user provides an explicit signature, we have to check if that's compatible with the inferred one, essentially.
Yeah, I think the thing would be to have subtyping, right? You would need to have the uh,
Structural subtyping, basically.
yeah, because we need to compare. Okay, this fulfills this type, but it has more stuff beyond what is specified here, right? But it's still part of that.
Yeah.
Yeah.
Fun.
Um, Yeah, but about signatures in particular, we should probably figure out a better way to represent them because here we just have a type which is a list of clauses, which is basically saying, hey, here's the source code of the signature. But actually, we don't care about that, do we? Um, we care about whether or not a given module satisfies a signature, and if we have to look at the signature source every time we do that, that's going to be incredibly inconvenient. Also, we need to check if the signature is well formed, right? If there are no name collisions and whatnot.
Yeah, but how can we avoid those two problems? I'm having a hard time figuring out. Okay, we don't want to be to like doing lookups every time in on that list, which is very inefficient. But at the same time, we have our signatures are basically because of the homoiconicity that we're trying to go for. We are reusing the data structures of normal clauses for the signatures body.
We're reusing it for the signature body, but that's not the same as the resulting objects that you get from evaluating the signature
Yeah, but,
necessarily.
yeah, but how are you gonna not do that?
Well, we need to define another type an interpreted signature, which let me think for a second. We need to be able to say that a signature contains. Actually, let me go to the here. Yeah, we need to be able to say, okay, these signatures contains these predicates and these modules and these other signatures, right? Essentially.
Yeah.
Um, so we should probably define a type for that, and then whenever the compiler hits a signature declaration, like this one, we need to be able to say, okay, I'm going to walk through the signature body and turn it into a more convenient data structure that matches the type that we have defined, and we save that in the compiler context instead of just the source code.
Okay, so you're proposing to have like a data structure that instead of having being a list of clauses, you like manipulate the list of clauses to be that data structure. But then my question is, what that would that data structure be?
Um, I'm thinking it's probably just gonna be a pair of maps, actually.
Okay, so a pair of maps. What is a pair of predicates and a pair of directives? That's what you're talking about?
Yeah, one actually not even directive. It should be one for predicates and one for nested modules or signatures, basically.
Yeah, which are directives, right?
Well, no, actually, a directive can specify a module or a signature, but a module and a signature, respectively, are not the same thing as the directive that generated it, is the point.
Wait, aren't modules and signatures instances of the concept directive? That's what I remember.
No, no, no. A directive is a concept from the source code representation of the language. It has nothing to do
Ah,
with
okay,
the.
okay. You're talking about already being transformed after. Okay, that's fine.
Yeah, 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 yeah.
Okay, so I agree with that. So let's just go with that then. So it's gonna be
Mm,
a pair of maps, one holding the predicates and another one holding everything else.
yes. And I'm wondering if we could use a set for the predicates, but that sounds like it will be painful later when we introduce types.
I don't see the sets being worse for types later. Could you elaborate that?
Because if you use a map, you have to associate a pair of name and arity with a tuple of types for the arguments, right?
No, in the future, yes. Right now, I don't know what we're gonna do with these underscores.
Right now, we actually don't need to care about them, which is why I'm wondering if we should just use a set for now.
Ah, but in the future, we would do a map because we would the key would be the name and the arity, and the value would be the type signature.
The value would be the type signature, yes. The signature, a tuple containing the types for each argument, essentially.
I'm starting to think. Um, how can I say this? Um, no, yeah, it makes complete sense. I think we can go with either of them, either a map or a set for now. I don't think it's gonna be a pain in the ass later because the compiler will tell us where is wrong, so we can just replace the wrong places. But now I
Mm.
have a question. We are doing all of this shit in the compiler, man. Shouldn't we be doing a type checker like before compilation in its entirety? I'm just realizing this is a static check what we are about to implement, right?
Well, it's dynamic from the perspective of the compiler.
Yeah, but that's always true, isn't it? But from the pipeline's perspective, this is a static check, so this should not live in the compiler
Why not?
because it's faster to just check the types and break and then throw the error message faster that way.
How are you going to check the types if you don't know what they are?
What do you mean? We always know what they are. That's what we're doing right now.
No, 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 no. If you just have the source code, like you have a bunch of directives and declarations and whatnot, um, you need to look at the directive and then you need to interpret that directive into a signature or a module, which are the directives we support at the moment, right?
Yeah, and that AST should be passed to the type checker. The type checker ignores everything aside from checking signatures, modules, etc.
Uh, I mean, we can do that, but that would imply that we. What would that imply? We would have to
That
separate.
would be a weird checking, right? Because we would be like being strict about modules and not caring about predicates because we don't have types on the predicates yet, right?
The problem is that you need to interpret the signatures to have the types, and you need to interpret the module to have the implementations, and then you have to check if they match, right?
Exactly, and that has nothing to do with code generation. That's why I think, well, at least usually, I'm not saying we should do that just for the sake of it, but I believe it's a good decision that we do the static checks before doing the more expensive stuff, which is the code generation.
I mean, we're gonna have to do that regardless. Um, it's just the
No, no,
question
no,
is,
no.
should we do it
Doing that
as an
regardless doesn't change the argument because the argument of doing
No, 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 no.
a simpler operation, which is quote unquote type checking, is then we can more quickly report the problem because we're skipping steps. We're not doing as things as expensive as the compiler is doing allegedly. So we're just checking if things are correct and then go passing to the compiler, and we can even pass the environments of the type checker too. Like, let's say that we do that. The local signatures and the local modules will live in the environment of the type checker then, or module checker, or whatever we're gonna call it. And then we can just pass that environment to the compiler to help with the compilation process.
Okay, in that case, we should define another AST then.
Yeah, but no, but that's the thing. That's exactly one of my problems with the that I have, is that usually you have type information. You make an AST. The AST has type information. Let's say the compiler, when it's the time of the compiler to do shit, the types don't matter, right? They should already have been removed.
But
That's why.
the type checker is a part of the compiler, Lemus.
Well, usually it's described as a step in the compilation pipeline.
You're basically preaching the idea of erasing, right?
No, no, no. Yeah, but that's where it gets a little bit how should I say gray area because here's the thing. There are papers there about strategies that okay, how should we handle the AST if we have multiple steps and there is data that is useless for the further steps. So there I already seen like the one paper is the trees that grow, right? That I think Haskell uses. So it's essentially a type level programming that allows you to shrink or grow the AST on demand. But when I ask the people that do compilers for like seriously as a more serious hobby, they always tell me, man, just do the AST transformation by hand. If you have an AST and you have another AST and you're not going to be able to avoid, the best way is always to do it by the transformation by hand. That's
That
why the
sounds very
parser clause
pleasant.
f becomes the clause f, and we do that by hand.
Man, at
We
that
already had
point,
this
why not?
conversation.
I mean, I can kind of understand why not just do splattered in the compiler, because then you have things that are just tangled together, right? Uh, but I don't know.
Okay, but
That's
what's your opinion, Magito? Because Marinho wants to do the static checking throughout the code generation process.
yeah. I think that may be messy.
That's a natural consequence of taking a module as a compilation unit, though.
Is it? Let me
Well,
think.
yes, because if you're compiling a module, you have to look at all of the signatures and modules used by that module, which you presume are already dealt with, right, by a previous compilation.
Yeah.
Then you have to check that their uses are correct in the local context, right?
Yes,
You
you
have
need
to do,
to, yeah, you need to satisfy the implementation interface, and
and then you have to derive the signature of the module that you are compiling, right? Because you need to infer that from the body. Possibly you may need to check if the derived signature matches a given signature, right? If you have an explicit annotation on the module.
Sure.
Um,
I think I'm okay. Maybe I'm skipping what you're saying, but I see one problem of handling modules as values is that you could just
but
flatten them all and get rid of them, right? As handle the signatures merely.
even if we do that at runtime, which we will, that's not the case at compile time.
But here's the thing: none of what you said must be done tangled with the code generation.
No, 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 no. But hear me out, okay? You do all of that, and then you emit the code for that module, right?
Okay.
But then that module will be used by another module, which will do the same thing, right? This interleaving is natural if you compile the modules independently.
Oh, okay. So what you're saying is that instead of type checking all the modules beforehand and then code generate for them, the pipeline that you're proposing is you check, you generate, you check, you generate. So you're gonna
Yeah,
keep
so it's like
interleaving.
multiple micro steps, right? Instead.
Yeah, and interleave the steps because you could just type check the entire chain and not compile a single thing.
You could, yes.
Uh,
Um, but there are a couple of problems with that because if you, let's say that in the middle there is a type error, what are you
yeah,
gonna
I
do
was
with the
thinking of
things that you
errors.
checked beforehand? Are you gonna drop it?
Well, right now, yes, but in the future, no, because we can just cache the result. If there was no error compiling a module,
No,
there's
no,
no
no, no,
reason
no, no,
to
no, 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 no.
recompile it
You
just
said that
because a user
you use the word
fails.
compiling. I mean, I'm
I
comparing. I'm talking about just the type checking on the strategy that you type check everything
Here's something
before
that
doing.
may be useful with this. Since you're isolating the scope of proving, right, if something is actually conforming with what you want, so that would be the code generation and the type checking, both of those steps chained in a small steps. I think what that gives you is more uh, depth in error reporting because you can report more errors that are independent, you see? Of course, you may also get errors that are just consequences of other errors that will happen, right? Um,
Right.
but I think you gain a lot more because if you just had a single pipeline and you have an error there, then you need to stop the code generation and do it again. You see? So that's kind of seedy, I think. So yeah, I think this approach is more interesting.
Wait, which approach you're talking about? The one that does the interleaving?
Yeah, the doing micro passes, right? Let's put it that way. Like assigning blocks and then looking at the blocks of each module.
Um, I I understand what
Like
you guys are
where
saying, but at the same
where
time,
like where that should go, I think that's up to debate. But I think the strategy is interesting, at least.
yeah, but if you change, like, if you have a module chain and you change the first module, you're gonna have to redo the type checking anyway. Like,
Well, yes, but if you have
Yes.
two module chains that are independent, do you need to redo the type checking for the other chain because the first one failed?
I'll be right back. I'll leave the important question for Lemus.
Okay.
okay, here's my proposal, Marinho. My understanding right now is that all, like, let's go with whatever you feel more comfortable with, which is probably the interleaving. And then later we can try to have this discussion again because I don't know how messy it's going to become because of the tanglement. Because I really don't want to
Lemus,
waste time compiling shit that will not type check.
Lemus, the whole point of a module is that they can be compiled independently and linked independent.
I
Well,
think that's an unfair assessment of what modules are useful for.
that's kind
Um,
of the that's kind of why they exist
that's
at
why
all,
they
actually.
exist as compilation units. Not every language that has modules needs to deal with them as compilation units. They are there for other reasons, especially semantically, not because they allow you to compile in a particular way. But let's go with your strategy for now. I want to know how tangled this will become and how wasteful in terms of time compiling useless shit is gonna be.
Well, it's not useless because, like, if you have a module A that uses a module B and you do the interleaved strategy, you type check module B, it passes. You can
Yeah,
cache that.
that's gonna be
Then you
used.
type check module A, it fails. But then if you adjust A and have to type check it again, you don't have to do the type check for B a second time necessarily.
Yeah, so that's the thing that I'm trying to that I'm that I don't see how we are addressing, because if you are assuming that you're gonna have errors between modules. I'm assuming that you're gonna have errors inside the module, but you already compiled some shit, and you have the nested module situation, right? That if a module
Ah,
inside a
no, no,
module
no, 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 no,
breaks,
no, no.
what
Lemus,
are you
Lemus,
gonna do
Lemus,
with
Lemus.
the compiled things that from the outer module?
Lemus, you are not going to compile the. I mean, we could just fix that by reordering the clauses, right? Like, if we push all of the directives to the top and deal with them first, then the problem that you were talking about doesn't happen.
That's true, but we're not doing that right now. But we could.
Okay, let's do that immediately then.
Oh, you really, you
Uh,
really do want to do the interleaving, don't you? That should probably be done by the preprocessor, man. Like, the compiler shouldn't have to care about this shit.
that is true. Let's see. Let's see.
Let me think for a moment. So, yeah, it's whatever we are compiling a compiler directive to a directive. It's in a parser to clause something. Parser to compiler. Yeah, parser to compiler. Whenever we are compiling a parser directive to a compiler directive, which is the clause, yeah, I think it's 134. That's when we have to do the reordering. So it's in that list concat map over there.
No, this doesn't quite work. I mean, we will have to do it here, but we also have to do it with
Yeah, yeah, of
the
course, of
overall
course.
thing as well.
Yeah, of course, of course. Because this is a recursive function, so we need to do with the overall thing anyway.
Let me think for a second. This takes a parser clause. and turns it into a list of
Oh, and just for
clauses.
recording purposes, my argument still holds because now instead of wasting time compiling, we are wasting time sorting it. So the waste is still here. There's no free lunch.
Your way would also be wasteful because then you would have to keep retype checking
I agree,
the.
but supposedly type checking is supposed to be faster than doing code generation. That's the entire point.
No. But you only generate the code if the type checking passes per module. I'm not arguing you should interleave the two beyond that.
No, yes, but we are interleaving per module. Like you type check, then you generate. You type check, you generate. And then there is a time being used to generate code that maybe that because of the type checking is going to be dropped anyway.
No, because if the type checking for a module fails, we stop compiling that module
Yeah, no, and we need to
before
save it.
generating any code.
Um, yeah, no, but are we going to interleave things within a module?
No, we shouldn't actually.
Okay, so we're
Like
gonna
if you look
okay
at
the granularity is module. That's the atomicity level.
yes, the first thing you do is you have to type check the module, and that may require you to first compile other modules that you depend on, right? That's where the interleaving comes in. But you only generate the code for the module that you are compiling after you type check it if the type checking succeeds.
Okay. Okay, we are just reordering it to be faster then. Because it would work anyway in your case.
Yeah, like the idea here is to try not to work at a global level, if at all possible, because we want to be able to eventually parallelize things.
No, that makes perfect sense to me. Like I do agree with the functor, well, with modules being the compilation units, right? Which, well, if the modules are using other modules, they'll become functors in the compilation, but that's a separate matter. We are just reordering it because we want you to fail faster when you're using the compiler.
Yeah,
That's
yeah.
fine. Yeah, that's very fine. Okay, this list concat map needs to be an let, and we need to have a sorting function.
We
And
need to
then
have a
whoever
sorting
is calling
function.
the parser to compiler the first time also needs to call such function. Yeah, it is
Yeah, I
there.
think it's down here
No,
somewhere.
it's up there. Parser to compiler is being called at least 3 times. Yeah, there we go.
What am I doing? I have LSP.
Yeah. Yeah, so all of these instances we have to deal with it. Um, yeah, man, just grab, let's make a function that receives a list of clauses and returns a list of clauses. I'm starting to regret using lists because now we are doing so many passes in this preprocessor that probably we should have been using finger trees from the get-go.
For sorting, I don't think it matters actually.
Well, but we're not starting. We are doing modules already. This is not a start.
No, not starting, sorting.
Oh, sorting. Let's make a sorting function that receives a list of clauses and returns a list of clauses.
Actually, is there a list dot sort? There is.
Yeah, we need to implement at least the lambda there.
Okay. In that case,
Compare the
let
clause.
canonical order.
Sure.
Actually, that's not really a canonical. It's not a total order. Yeah, but regardless.
Yeah, this is not a total order because we are not ordering the modules and signatures, right? We are only sorting them inside a module. Why are we gonna do this on the level of parser clauses? Is that a reason?
Because it's a list of parser clauses, right?
Well, it depends. Are we doing this after parser to compiler or before parser to compiler?
That's a good question. Maybe we should do it after because there are fewer total clauses in that case because we may have merged some predicates into a
Yes.
multi-declaration,
Yes,
right?
that's true. So I recommend using ast.clause.t instead of
Okay.
parser clause.t. Let's
Oops.
do the usual trick. So let's make the pattern match on a tuple. Let's go for it.
Just let me list.sort. This takes 0 if they are equal, a positive if the first one is greater, negative if the first one is smaller.
This is
Okay, this
such
is
why, but okay.
well. Haskell
This
actually has a similar thing, but it uses a proper enum for that, right?
no, it uses a particular ADT just to describe, just to have better description of what the fuck you're doing. This is like a C inheritance bullshit.
Well, yeah, and Java does the same thing, by the way. Java
Yeah,
does the same thing, which is kind of sad because that means that Clojure does the same thing because of Java.
yeah, that makes sense. Well, anyway, so that's to
Match
yeah, match on the tuple probably, and then
with
we need to start defining who is greater than who.
um, okay, if the left one is a declaration
Probably you
of
should do a let
whatever,
open inside the body of this canonical order. Let's do let open ast dot clause
let open ast.clause
in
in. Actually, this would be a multi.
multi
Oh no,
declaration. Yes.
actually,
No, multi declaration.
oops, not
On
here.
the clause
Um,
level, we only have multi declarations, my man.
directive actually is what I meant.
Oh, okay. Okay,
Okay,
if
if
you
they
have
are
two
both
directives,
directives,
then it doesn't
ast.
matter.
Yeah, if they are two directives, then they are equal. If one is a directive
And the other one is anything else.
and the other one is anything else,
One.
then that's -1 because they are sorted.
Wait, I thought the positive is left one is greater, right?
No, no, that's sort. Um,
Positive integer if the first is greater.
which means if they are not
Oh,
sorted,
yeah, yeah, exactly. That's correct. It's negative there, which means that this one is positive,
this should be 1.
and
And
for
then if
everything
it's
else, probably it's 0.
anything else is 0 as well because the order doesn't matter in that case.
What the heck is wrong with this? What is there?
This pattern should not be a constructor.
ast.clause.t. What? Ah, you need to strip the location. That's the problem.
Oh, right. Let's do that.
Location.strip lock.
Location, strip lock. Let's do this
This
here.
could be just a strip because the location already has the meaning. But okay, we can
Okay,
change that later.
can do that later.
Okay, we have the comparison function. Now we just need to sort it.
Okay, so basically everywhere that we call parser to compiler, right?
Just put it after the multi-mapper, man. Just put it after the multi-mapper. I think that's the easiest way to do it. It's probably less efficient, but it's the easiest. Put after this concat map.
List sort canonical order, but we also have to do this inside of the inside of the
No, we don't. The concat map is already flattening it. We have a concat map down there, right?
that doesn't help for nested modules though.
Ah, fuck me. You're right.
Yeah, unfortunate.
Well, we could.
Uh,
No, we can't. No, we have to do it ourselves by hand. That's true. That is true.
okay. Here. Concat parser to compiler body. Yeah, we have to do something like body this, and then list sort canonical order. Like this, right?
Yeah. Yeah. Let's see if this compiles. Did you remember to pull, by the way?
Did you push something?
I remember I was driving the last time. No, you were the one driving last time. Okay, this build?
Done build. It does.
Yeah. Okay, nice. Man, it's so nice that we can do this type of shit because the locations are like already carried with the clauses. So, oh, you want to reorder your shit? That's not gonna matter for the error messages. So nice.
Yeah, that's very nice indeed.
Okay, let's start the last scope implementation then. Let's change the compiler state to be the pair of maps that you or the pair of sets, depends on your mood, I guess. And
Well,
then
it's going to be a set and a map if it's not a pair of maps.
yeah, because the predicates is just gonna like not care about the types. Um,
Let me commit this first, actually. Um,
You committed to it, Marino.
yes, because this makes our lives easier.
yeah.
That's good to know.
Um, handle directives first, so we can type check before generating code. Right, so now if we go to the compiler, if we go back to the compiler, um,
Man, like I think we are making the right decisions, but I can completely see people being pissed that we're not gonna allow them to do opens on the top level. And the error message should be funny, saying, "This is a no-no, and you know it."
we do not condone shooting yourself in the foot.
Oh man, that should be the error message. No joke. No joke, man. That should be the error message.
We do not
I.
provide you foot guns, so please do not use them.
I mean, we may provide other foot guns, but we don't provide this particular one.
It's not in our arsenal, so please go away.
I love it. I like that's what I meant last time when I said more creative and funny error messages. That like you're having a conversation with the compiler authors.
Man,
Okay.
actually, let me write that down because I don't want to forget this. Uh,
This is a no-no and you know it, or we do not condone the use of foot guns. Yeah, the shooting yourself in the foot. This is not in our arsenal. This is not in our arsenal. Uh, those are great. Those are great, man.
uh,
Why
yeah,
don't we go with like Microsoft level error
I like,
messages?
I like
No,
this one.
Microsoft's level error message is gonna be boring. It's not gonna be a conversation with us. And
But
I like the idea that by the error messages we are teaching you how to do programming properly.
uh, okay, let's see. So, first of all, we need
Change the
to
compiler state.
change the compiler state because, yeah, this, right?
Yeah.
Um, local modules, local signatures. we actually need to do type. What should we call this? Compile time entity or something?
Sure. Compile time entity is too long though.
That's a very generic name, but okay.
Well, it's an entity that only lives at compile time. That's why comp time. That's perfect. Comp time is okay.
Okay, so this is either module of um, module of. We need a map, right? We need a map. We need a string map actually.
Yeah, we already. Yeah, we can just use
That's
the
it.
batmaps.string.
A module is either a map, or rather, a comp time entity is either a module, which is a map of names to comp time things. Um, hmm. And it needs to also have the names of predicates, right?
Yeah,
So,
which for now
uh,
is gonna be a set of strings probably. Well, a set of pairs because it's just the name and the arity.
right, so it needs to be
Yeah, do another type alias, which is good. Probably should be predicate or something.
type predicate equals,
For
actually
now, it's gonna be.
predicate name is a string and an int.
Well, I wanted to make the alias predicate because in the future we're gonna change from the set to a map.
Well, it will be a map of predicate names to type tuples in that
Yeah,
case,
but
right?
then we would change just line 25. We would not have to deal with the comp time. But that's the same thing. Just I find it more convenient.
Actually, no, we would have to change line 28 because it would have to be like
Yeah, that's
set.t.
that's what I'm saying. If the set.t was on 25, you remove the underscore name and you just change 25 in the future. You see?
Okay, I guess. Let's call this then hmm,
Local predicate.
predicate. Well, actually, this can't just be a set because even though we don't have the type information yet, we need to have an optional implementation, right? That kind of sucks though.
Ah, because maybe you're not you providing. This is not a signature. This is a module. So there's already a
Well, yes.
declaration in there.
Yeah, if it's a module, the predicate's gonna have an implementation, right?
Man, I'm starting to think that combining everything in a single conf type is a bad idea because we want like things that are available for modules, but they will be forbidden for signatures.
Well, signature of
Yeah, but
um,
you're gonna have to inspect the value because everything is a comp type. You know what I mean?
I didn't follow. Go at it again, please.
Yeah, line 33 and line 35, they were made thinking that, okay, we are thinking about what is the necessary things for the environment of modules and what's going to be the necessary things for environment of signatures. Marinho is proposing to have a comp time type that is an ADT of both. But how do you know what's going
hmm.
to be the module data or the signature data? You're going to have to do a match, right?
I mean, we're
Because
gonna have to do that regardless.
no, you wouldn't, because if you had the separate bindings on 35 and 37, you would know automatically that this is for modules and this is for signatures.
Mm, but that's a foot gun because then you can have the same name on both maps.
Yeah, that's a trade-off that I agree. That did you get that, Mageta?
Yeah, I think I did.
Yeah, so I agree
Uh,
that's a trade-off. Well, let's go with
Uh,
this for now. That's fine.
um,
Yeah, but we need to handle the situation that you described, Marin. We need to be able to allow you to have an optional declaration, right? Actually, for modules, you cannot just have you need to have a full declaration.
yeah, actually, I'm not sure if this will quite work if I just put a comp time stuff here, because here's the thing. For a module, you must have an implementation for the predicate, right?
Yeah, you must. But for the signature, you may not. Actually,
But
for
for
the
the
signature,
signature,
are we gonna allow that?
no, the signature should not have an implementation. It's a signature.
Exactly. So I agree with that.
But also, the signature may say that you must expose a module, but it doesn't give you the module implementation. It may give you the module signature, but not the implementation.
Ah. Wait, but then that's still okay, right? What's the problem?
The problem is we can't just use a comp time and call it a day because we have to say, okay, a signature needs to be a map from names, comp time names, and predicate names. Well, actually, it needs to have the pair as well, but actually, let's copy this for now. So instead of being comp time here, this needs to be like, I don't know, it needs to be like signature, I guess.
Is my mic noisy? Because I'm
No,
using the improvised mic, but
no, it's not.
okay.
It is not. Hello, Ace.
We have the non-constructive person on the chat now because of the double negation.
Yeah, but that's fine. What's gonna be the type there? You're at work. Okay. Um, well, let's fix line 28, right? Line 28 is wrong. This cannot be a set of names. This must be a map
Yeah, this actually needs to be a map
from
from.
predicate name to, for now, just a declaration. The future is going to be a pair, a declaration and a type.
Right. Yeah, it's probably better to just hang the source code here because we need to. Hmm. We do want to just have a reference to the compiled predicates at some point, but that still doesn't solve the problem of, okay, I need to be able to. Oh yeah, no, this can be a pair of the original source code and an optional compiled version of the predicate, if that makes sense.
I don't think the compiled version is going to help us at this moment, no.
Yeah, it won't. So for the sake of our sanity, let's just say,
It's a
um,
clause.c, right? Well, that actually must be at the multi-declaration.
yeah, it needs to be a multi-declaration.
Man, let's
Um,
make a type for this triplet because that's starting to get repetitive. Let's make a type here, which is gonna be multi-declaration. Let's make that. Yeah, but then it begs the question. This should not be a triplet anymore. This is already named. This should be a record, but that's a future refactoring. Yeah, I need to change the type to deriving show probably. Yeah,
head, decal,
you need to put an and
decal.
as well on line 13.
Right.
Very well. Don't forget to expose that on the signature. Oh, there's no
This has
signature.
no
Yeah,
signature.
there's no signature
Yeah.
for that. Okay, now we can just reuse it in here. So this is gonna be a bat.map. Yeah, you're gonna have to do the trick on line 8. You see?
That's kind
Unfortunately.
of annoying.
Yeah,
That's very annoying.
that's very annoying. But well, it is what it is.
Okay, module uh, predicate map equals bet map make struct and we need to say type t equals what's the key? The key is
The key is gonna be the predicate name.
we already have a type for that actually.
Yeah, but we call it functor name. Do you want to reuse that? That sounds like a bad name, but well.
This is a map.
Just swap predicate name into the functor name and call it a day.
Are we actually using this? We are. Okay. Why? Why? We aren't actually. Okay.
Actually, we can also use the functor map already, right? The functor map on line 8 is already what we want.
It is. It actually
Maybe
is.
the name is not the best, but
Uh, yeah. Let me. Okay. Where are we using this? Only 3 places. Let's rename this actually to predicate name, right?
yeah, predicate name. But there it's duplicated up there. There we
Of
go.
course, because it would be too hopeful to hope that LSP would do what it's supposed to do.
Of course.
Um,
Um, yeah. Um, yeah, but the functor map on 13 is not what we want, right? Now we need to change that.
the T here is the type of
The key.
the key, right?
Yeah, it's the type of the key.
Okay, so this is going to be actually
ast dot clause dot mut declaration. Not with that. Yeah. Yeah, LSP we haven't done build, so this is fucked.
functor
Functor
map
map.t.
T.
This should not be called functor map, by the way. But okay.
This shouldn't, in fact, and in fact, we should rename this as well. I think.
Yeah.
Let's call this predicate map.
Yeah. Okay. No, you have to change everywhere. Don't forget. I thought you did a replace in the entire buffer.
I did an LSP rename,
Oh,
but
but
again,
yeah, but you
it's
know how that
too,
works.
yeah, no, it's too optimistic to hope that LSP does what it's supposed to do.
Yeah. It is what it is.
Okay, so we need to define a type for a
Of signature,
signature.
yeah. So a type for a signature. Huh.
A signature is either.
Man, but that sounds annoying as fuck. We have to pre-process the entire thing from the source code representation to this representation before doing anything about it. That's
Well,
annoying.
it's not. Well, we would have to do something similar regardless, even if we had kept the previous representation, because the previous representation was just another encoding of the same information that's in the source code.
Yeah, but it's less convenient for the manipulations that we are about to do, right?
Yeah. Let's see. Signature is either a plain signature, and these are terrible names, of something. Let's put unit here for now. To do. Or it is a module signature of. Um, actually,
Oh, interesting. The module signature.
because like I need to have basically this, except using signature instead of comp time on the left
So this
here,
should
and
be
the
a
right hand
parametric type.
side.
Yeah, this should be a parametric type. This tuple should be a parametric.
This tuple should be parametric.
Yeah, we should need to do another type, and then type receives an A, and then we apply the A on that. You know what I mean?
Let's do this properly then. Type a module equals.
Can can we actually do that? Yeah, but
Um,
probably you need to pass a B as well, because we want to swap the multi declaration there as well, right?
yeah.
Yeah, that makes sense. I don't think you can call that a module though, because this is OCaml. So that's probably not gonna syntactically be okay.
Yeah. Yeah.
Man,
Ellie
I
dent.
think we should consider making a module because all of these types are related to module things. We can do this later. Let's just do it flat and then we can modularize it later.
Mm, yeah. Why is this a syntax error?
I don't remember the order how you do a parametric type. Go to the location. Let's see there. The location module has examples. Yeah, line
But
14. That's how you do it.
why are we
But this
not
only
using
has
the?
one parameter though.
Magetta?
You know one good solution for this,
What?
Lemos?
What?
Using the OCaml object system.
Why?
The OCaml object system.
Yeah, it is like well, that was supposed to be a joke, mind you,
No.
but
Yeah, that's why I'm asking the.
but it
Yeah.
is fairly decent actually. It's well, it's more of the classical OP rather than Java, so it looks very weird today. But I think that could be useful. Like we could make
Is everything mutable by default?
uh I'm
I
not sure
think
if I
I
can
think the previous
answer
implementation
that,
of the
but
repo already uses the object system, so it's fine.
does it? Oh yes, it does
Parametric.
because the library, I think.
Yeah, exactly. Okay, let me search how you do parametric types with multiple arguments. Uh,
Do we have to use a tuple? Is
I'm
that what we
starting
have
to
to do?
I'm starting to consider that as an option. Wait a moment. Wait a moment. Yes. Unfortunately, yes.
Like this, right? Except this
uh,
doesn't work.
uh, I believe it's comma. Yeah.
Okay. Yeah, this kind of sucks actually.
Yeah, but well, it is what it is. There's nothing I can say about it.
And I found an old website when OCaml was just CAML, talking about the object layer.
Yeah, let me tell you up front. If everything is mutable, Marinho's gonna vote against it.
Like, well, it is about message passing, so but there's no reason that I can tell that it is mutable.
We
So
agree with you, but people make decisions, and some decisions we disagree.
yeah, I need to understand how it works. I never really used it.
This needs to be recursive, doesn't it?
I don't think you need to do that for types. Only for
What? Sorry.
functions. Do you need to put the rec keyword for recursive types?
As far as I know, no.
Yeah, I don't think so. I think it's yeah.
Multi-declaration unit, I guess.
Yeah, okay, let me try to
Uh,
understand what the fuck's going on. So
that's
you
not a tuple though, but oh no, okay, you're applying to module. Okay.
yeah. The comp time type is either is a module. Okay, so this is on the top level, right? So this is on the top level. If let's skip module for now. Let's say that you have a signature. If you have a signature, you're gonna have. Is this correct though?
Well, you need a map from names to signatures
Yeah, that makes sense. And why do you need the predicate name to the set of predicate names?
because the signature may specify that a module must export some predicates, right?
Because a signature may specify. Oh, this is the list of exports.
Basically, yeah.
Okay. Can you put the example on the right buffer, please?
Modules. Actually, yeah, here.
Okay, so the sig A on line 1 is the key of the map on the left. And then we have the list of exports. No, man, but the list of exports is in the body of the signature, isn't it?
Well, we will have to convert that to something.
To a set of predicate names.
Yeah, we have to collect these into a set, and these we need to make a map mapping their names to their comp time values, basically.
Okay.
Actually, there's the slight difficulty that a signature may give you an abstract signature as well. So
Abstract. That's it. You may have an abstract on the ADT. That's it. Okay. So we're gonna collect all the predicates and put it in the predicate name set. That's okay. Now let's go to the signature type. The signature type is either a plain signature, which what the heck is that supposed to be? Could you give an
you may
example
have a
using the buffer on the
you
right?
may have a nested signature here. Like you could say, okay, SIGB is abstract, but you also have
Oh, line 13 then.
line 13. Not quite actually.
Oh, but this is not in a signature. This is in a module. So it's a signature inside a signature.
Yeah, you may have something like signature concrete, which has a body. You see. And
Mm-hmm.
then inside of that, you say, I don't know,
Mm-hmm.
how about
Okay,
there's
but
another
this,
signature
but then
here.
this is just recursive. Why is this unit on 27?
Because I just put it as a placeholder, actually.
Um, yeah, just copy paste line 33, right? The type of line 33 and 27, the contents is going to be the same, isn't it?
Well, in that case, actually, it's better to do it like this.
Yeah. And then you also may have a module signature, which is defining what is going to be the module that's going to be exported. That has a name. Well, that's a module T, which means that we are using the type on line 24, which has a predicate map. Oh, because it may also contain implementation. And it also has the module name. What is the unit doing on 29?
Because we actually don't want to store anything here.
Okay, I'm gonna say something. On line 24, replace the A and the B with better names. What are those actually mean, please?
Is no Haskell.
Yeah, fuck that. So what
Okay.
is the A? This is the value of.
Uh, okay, this is the value of comp time entities.
Okay.
Actually, let's put it in the singular.
And the B is always um, definition, predicate definition.
Well, it could be the definition, but there will probably be more things than just that. Let's use definition for now, though.
Okay. So you're using unit because there will be no implementations.
Because, yeah, this is
Okay.
effectively a set because
Okay.
the value associated with the key carries no information.
Okay. But we are
Which
doing like
sucks
this.
because in OCaml this actually takes up space. In Zig it wouldn't, but oh well.
Life. Okay, we have our types. Let's finally do 41 and 43. What are we going to be putting in there?
Um, Actually, I think we can just replace all of these.
With comp time. Damn.
Yeah.
Could you please call the comp
Um,
time key env, please? I that's gonna confuse the shit out of me later. Yeah, thank you.
But this is not quite correct because we want this to be a module, right?
What do you mean?
Do actually do we? Because if we compile a signature, then this needs to be yeah, no, this is okay actually.
Okay, everything is gonna break. So let's go to the compiler and go through the compilation errors now.
Mm, actually, define symbols, local modules, local signatures. This is basically, well, before we are doing that, this is actually this, in fact, because this is just the set of defined symbols, right?
Uh, yes.
Actually, not quite, yeah. Hmm. Okay, this is kind of weird, but I think this is correct, actually. We put this here, but instead of being a multi-declaration here, this is actually unit.
Wait. Why? Why we have to do that instead of just comp time?
Because we want to replace these three things, right? This can go away because this will be folded together
Comp time.
with the comp time, yeah. The this.
Yeah, but
So
what
this
about the
can go
defined
away.
symbols?
This is the local modules which will actually have. Actually, this can just be the signature, in fact. We don't need the bodies of the modules at this point.
We don't need the bodies of the modules. What do you mean? I'm confused.
Like we just need the signatures actually, because we're gonna link things by name at the end. So actually, this doesn't have to be a comp time. This can just be signature, in fact.
Wait, man.
Yeah.
I'm confused. What do you mean by not having? We don't need the module definitions right now.
Because like what we're gonna do if we're just compiling a module, right? We first need to populate the environment by compiling all of the directives that are at the top of the source file because we put them there, right?
Mm-hmm.
Um, but we actually don't care about the module bodies yet. Actually, should we?
We
We
man,
probably
we're gonna
should.
have to pre-process the thing. We're gonna have source code of the modules. What are we gonna do with them?
That's
Let's
a good
say
question,
let's
actually.
say that the module comes first on the file on the right, and the signature comes after. What are we gonna do with the module? We have to save it somewhere. I thought that was the purpose of line 34.
Okay, let's actually put this here then.
Sure. Okay, this makes total sense to me. Now, uh, yeah, now what we gotta do is go through the compilation errors because there will be shitloads of them.
Of course, this is going to fail. Let's
Initialization
see.
is completely fucked.
Yeah, this can go away. This can go away. This can go away. What we need is we have a header, we have an output. We need. What do we need? We need
A way to have an empty env.
env equals. This is in fact a pair.
Yeah, tuple. And each one of them has a name. Should have an empty thing. So it's gonna should be batmap.string.empty, and predicate map.empty. Yeah. Next error.
That's it actually.
Wait, we were not using the find symbols. Okay, we created that last like sessions ago and we never used it. Okay then.
Uh, yeah, turns out you don't really need that because the bean can handle forward declarations for you just fine. Like
Yeah.
the AST format doesn't care about definition order.
Okay, now go to the place where we have the to-dos. Compile, I think it's compile directive function.
Hmm, compile blah blah
Yeah, there we
blah
go.
directive here.
This is now we have to start doing the things, right? So I propose first to start with 170 because signatures are should be definitely easier than modules. But now I'm not too sure now that I have the AST.
Nah, it should be still easier than modules because like a signature is just gonna have a bunch of well, it's gonna have a bunch of multi-declarations with one body, which is empty, right? And if there's stuff here, that actually should be an error. Like if you try to do this.
And we need to recursively check the argument names to be underscore for now.
Yeah, that as well. Um, then the directives inside of a signature, they have to be modules or signatures for now, right?
Yeah. I'm starting to
Okay.
think we should have a directives.ml file, man. This is gonna be huge. All of these things, and we put the types there as well. What do you think?
We can do that if the function gets too large.
Okay, let's just start with 170 then. So you have signature one. So the first thing I gotta do is inspect the elements, right? Because we need to get the name of the signature out of it.
Mm, yeah, actually, let me make this a separate function first because um, I don't think it's gonna look nice to have all the logic in lines here. Actually,
Mm-hmm.
let rec compile
Signature.
signature. Um,
You should receive the body and the elements out of 163 and the compiler, of course. Yeah, that triplet 163. You should receive all those three things. It doesn't need to be in a triplet though. It can be separate arguments.
elements body compiler. Elements body compiler. Yeah, this is what we want. The body is actually, yeah, the body is this. The compiler is this. The elements is in fact a list of expressions.
Yeah, and it's already a problem because we need to see if the length is one, and if it's an atom, right? Things of that nature.
Um, yeah, the length needs to be one, and in fact, we can probably do the check here, right? Because if the length of element is anything other than one, that means it doesn't match the expected arity, which means there's an error in the compiler somewhere.
Yeah, we should definitely do that.
Um, match elements with um, signa sig signature name.
Name, yeah. Well, not really, not
Um,
really. You have to go further because it's a list of expressions. We need to also verify which expression it is.
right. So actually,
It
this
could
needs
be
to be
another
an
functor.
ASCII dot expert dot um,
Functor.
This is kind of annoying because we need to check if it's a functor and the elements inherity is
We can
empty.
make
Actually,
we can have a predicate to check for an atom inside the expression module, and then we can use a guard in here.
we kind of have that, don't we?
Yeah, we have is
Actually, no.
functor, but we should have is
This
atom.
functor. We should have is atom. That is true. Functor of func. I mean, we can just do this, no? Like, func. Name elements must be this. Elements equal this, and arity is 0, right?
Yeah, but the function will do that for us. And there is a typo in elements.
The name is just a string, right? So
yes.
Name.
Yes.
String.
Okay, but we need to do the exhaustive pattern matching to and report some errors.
Compile signature. Name body compiler. Otherwise, what's the problem?
Go to the type of expressions.t. I think we also have to strip locations in some sense. What is the type of elements again?
What's the type of elements? It's a list of expressions, but in this case it needs to be empty.
No, yes, but the list of expressions is what is an expression?
Oh, this actually has
location
that's true.
Right? Yeah, so just put in the beginning open curly brace content equals. No, before the actually there, sorry. And then underscore, that. We probably want to keep the location though for the compiler signature. We may want to keep that, so we may send that as an argument to compile signature later. On line 178, you do the same, but you do lock and under semicolon underscore.
Okay, this is kind of messed up. That's better.
Yeah.
Lock. Let's put this here for now.
Yeah, but this is the location of the name, man. I don't think this is useful, actually. We need to save the location of the entire signature, not the name of the signature.
We need the location of the entire... That's fair, actually.
Yeah, so the 178 is still underscore, but we have to find the location. For some reason, it's not in the arguments. So where are we calling compile directive? Could you go there?
We're calling it here.
Oh, there we go. We are doing .content. You see on 191. Send the clause.lock as well to this guy.
We can do that, no problem. Let's put this here.
Nice. Now we need to put the location as a thing in here, as a potential argument. .t probably. Yeah. Nice. Okay, 179. Directive location. Yeah, that's better. Definitely better. Okay, 179.
Let's be consistent. Oops. And let's flip these.
Yeah. 179, remove the catch-all and put open and close curly brace, lock semicolon underscore.
Remove the catch-all.
Yeah. We need to extract the location out of this pattern matching here, because we need to report that.
Okay. The
Wait a moment.
content.
No, but this is a list, right?
This is a list, yeah.
Okay, put underscore there. Well, actually, you don't care about the content at all. Just keep a singleton, but get the location. And now, instead of simply unreachable, it's going to be log.error, for sure. And you need to pass the location as a first argument to that. And the string should be signature names must be atoms or something like that.
Okay. Signature names must be atoms.
And this pattern matching is not exhaustive anymore because now we need the multiple list now. That's the next case, which is signature should have only a name in its. I don't know how to say that, but the location should be the directive location, not the lock. Yeah, I don't know what to put in the error message though.
Signature declarations must have only the signature name as an argument.
Yeah, that's good. Okay, now I think we have a type problem with the error. So this is a location.t. What is error expecting? It's a location.what?
Location.location.
Uh, it's a location.location. Do a dot on it.
Actually,
Yeah, just grab the
T.
start. Just grab the start. T. Sorry, it's there.
Yeah, it expects a location.location, which is actually a pair. Huh. Well, it's a record actually.
Yeah, it's for the beginning and the end of the thing that was parsed.
Why is
Yeah, I think this is wrong. Yeah, this is already a location.location. The type signature is wrong. That's the problem.
Yeah, let's fix that. So this should be location log location, and this
And
should
over there
also
as well.
be the same.
Okay, I think we have enough for this function. Now we'll just compile signature is missing. Are we missing any case, any important case that needs to be reported?
There is one case that should have a different message actually.
Okay.
Um,
Man, this looks so nice. We already have all the pieces, the building pieces to report this properly. That's so awesome.
Signature declarations must have a name, right?
Yeah, but the location. Yeah, no, that's correct. That's definitely correct. Nice. We can already test this out, right? We don't need to compile the signature. Well, we could, but to see these error messages, to test those out, we could just make an example. Yeah, just return the compiler on 161. And put underscores on the names.
This is not recursive yet. Okay. That builds.
Yeah, no, but I want to test it out. Like I want to make an example that will break, so we can see the error messages like working properly. Because this is the first use case that we are using the locations for something that is not unreachable and not a syntax error.
I mean, we can do this.
Sure. Let's see what happens. Dune exec karuta -- compile.
Dune, not nude. I need to be able to type. That's a problem that I have sometimes. I don't know how to type occasionally.
Exec
Dune,
karuta.
exec, Karuta.
And
You know
there's a
what's the
typo
most,
there.
you know what's one of the most popular metrics for hiring somebody nowadays?
What?
The words per minute the person can type.
Damn. They think programming is typing, guys.
Yes.
Well, prompting is typing, no?
Well, No, you need to. I mean, somebody has to think somewhere,
Yeah,
right?
so
And that's
somewhere
the
in the
insane
chain
part.
there must be a brain.
I mean, if I
Well,
hire, if you're being high, if you were, I could conceive you hiring someone based on data heuristics if it was like 5 years ago and you were being hired to do Golang, because you're basically gonna be writing, right? So I
Ooh.
can understand that.
Oh, you need to delete everything else. Okay, yeah, delete everything else or comment everything else.
delete everything. Wait, unexpected. Why?
Yeah, no, we definitely have to figure the shit out of that. That doesn't make any sense, right?
It doesn't.
The parser is wrong. Actually, which one you want to fix first? This is more concerns me more though. Unexpected closing bracket.
Unexpected question mark. Yeah, that's definitely wrong. We should fix that.
That's very wrong, man. That's like surprisingly wrong. You know what? Delete line 1. Let's just keep it as it was before.
Hmm.
Yeah, it's fucked up beyond belief.
To be fair, I don't think this was parsing before regardless, or was it?
Well, of course it was parsing.
Because we changed the syntax, right?
Ah, yeah. Okay, we have to revisit the parser. Yeah, let's do that. I think that's more emergent than urgent than what we are doing now.
Okay, let's see. Um, let's look at this first, actually. So,
Yeah, directive underscore. That's what we're looking for. Yeah, so holds functor lem and then a dot.
yeah, so we can have
Okay,
something
okay.
like,
Comment everything, and just put signature dot. Let's try that first.
oh, wait, does Prolog not use percent sign? It should,
Yes,
right?
yes, but did you teach Cocoon to interpret Karuta as prologue for now?
I did.
Yeah, so it's broken.
Oops. Okay. Whatever. If I can type.
Yeah. I wanted to put signature there already, so you can try test two things at once. This
Sounds
is a
so excited
compiler
to be
bug.
honest.
Unknown directive. Thank you, compiler. Signature. Unknown directive. Ah, because this is a signature slash 0.
Oh, wait, that means, in fact, then that, oops, this, here. Yeah, this is never gonna match then, is
Yeah,
it?
yeah, but I think we could be more specific about the error. We could do signature 0 and do a proper error message for that instead of the catch-all on 191.
Well, this needs to be something like then, somehow there is a mismatch between the expected arity and the
Yeah,
actual
but this should not be an
arity.
error. This should be unreachable.
Yeah, this should be unreachable.
Yeah, but we could make a proper error message for signature with arity 0 though. Do you agree?
I agree. Let's do that right now, actually.
Yeah, that's very easy. Error,
Error,
directive lock.
directive lock, um, signature directives must have a name.
Yeah, let's try this out.
There we go.
Look at it. Remove the brackets, please. Yeah, now run it again. Beautiful. Look at it. Isn't it
What I,
nice?
not what I would call beautiful, but okay,
No, man, come
interesting.
on. Come on. Okay, now let's have some. Wait. So this is okay. The parsing until now is correct. Let's try to put a name there. Oh, it
That
actually
works
worked.
actually.
Okay, so the problem is on having a body for the signature, apparently.
Okay, let's give it an empty body.
There we go.
Yeah,
Okay, this is the problem. It's 95 probably.
we have a functor. Then we have a directive left the limb, which is
Which is the open curly brace. It should be the open curly brace. Oh, those are
yeah. This
swapped
is
around. That's the
yeah. This
problem.
is backwards. This is totally backwards.
Okay, that helps.
Okay.
Okay, actually that was fast to fix. Um. Okay, so now. Okay, swap the ABC for a functor. So put brackets on it. Well, put brackets with something else because this is still gonna
Yeah.
work because that's an atom. Yeah.
Signature names must be atoms,
What's the
right?
other ones? There were I think we're still missing two. Isn't this
Um,
nice, Marinho? Look at it.
no,
It
but this one
works.
is supposed to. Yeah, this is unreachable. If this ever happens, there's a bug in the compiler.
Yeah,
It's not a
that's true.
user error.
That's true. Yeah, I think we already tested all the cases that we can easily test, so we can proceed now with the compile signature.
Actually, let's put a catch-all here and say signature directives must have only a name and a body.
Yeah, that's fine. I'm in favor of more descriptive error messages, so
Okay, so check this out, guys. I'll send on the chat. Just look.
yeah, there we go. Here it comes.
That's very nice, actually.
She sent multiple things in pieces and said any modification, just let her know.
I gotta be honest, the one on the left is awesome, but I have problems with the square one. I think it's a little bit too polluted. There's too much stuff. The thing that I like about the full one is that it's a very good use of empty space. But the square one, I think it's a little bit too much. What are your guys' opinions are?
I like the flowers, but I think for our logo, it would probably be better to get rid of them.
I'm not against having flowers. Because we have flowers and we have a branch on the background.
Yeah, I think the branch behind the owl is too much.
Background.
Yeah.
Yeah.
Yeah, I
Uh,
guess that's.
like
She
one of
sent
the.
uh
Mhm.
she sent the pieces as well, by the way. Like so here's the
And by the way,
background.
you should praise her for the good use of empty space, man, because that was very, very good.
I mean, she does one thing, right? So
No, but that doesn't mean doesn't deserve praise.
she sent all the pieces, you see?
Yeah.
So she sent these as well, which is like she said it's like a poster version that has her signature, but you can compose whatever way you want. That's just for like a banner, right?
Yeah,
Things like
these will be
that.
on the website for sure.
This is really
Uh,
nice. I like it.
okay, so I'll ask her to remove the branch, and I think that's it.
Yeah, no, no,
On
no.
the
Here,
on the
yeah,
icon version, yeah.
yeah. On the icon version, I think we should not have the branch. And if you want to keep flowers, I would keep only two, one in each corner,
One on each corner.
diagonal.
I think that's weird.
No, no, no. Not on each corner, four corners. Only two corners. Because if you remove the branch, there's going to be only two flowers on the square one, right?
Yeah.
Yes, which I think they are in a good place.
Oh, so you'd keep both of them there and have the empty space on the other side?
Yeah.
Yeah.
Marin, what's your opinion on it?
I agree with Mageta actually.
Let's go with that then. Oh, we also have the color of the background. Okay, we should put the poem, the other Karuta card with the writing, with this background color and this green border as well.
Yeah, I'll edit that on GIMP now.
Yeah, that's
So
very nice. Okay, what are we doing here, Marinho?
Making sure this is not too much of a catch-all, so we can reorder the clauses
Yeah.
and not shoot ourselves in the foot.
Man, but like, do you like the error message pointing to everything? Because let's say that you have 20 arguments in the signature. It's gonna print the entire line. I kind of like, I don't know how to fix that, but because we can grab the locations out of the elements, right? We know how many elements there is because we know the arity. So we
Yeah.
could, in theory, extract locations out of the elements that we know are wrong, but to not have, well, that's a future improvement. But I think you see my point, right?
Yeah, we
It's
should
pointing to
probably
the
use.
entire expression, see? So if you have a
Yeah,
body, it's
no.
also going to be fucked.
Yeah, no, I agree. We should probably change the. I think the this thing here doesn't have a location in the AST. Like we have a location for the entire thing. We have a location for the elements for each of them. We have a location for the body and its contents, but we don't have a location for this. I think, but that's
No,
easy
we
to
do.
fix
No, no,
though.
no, wait, we do. That's the functor, right? That's the full functor. That what you just highlighted there.
MLI here. That's just it. We're using a functor with two R's, right?
But the functor has location, no? It's supposed to have
It
location.
does. It does not actually.
Ah, it's because the inner pieces have location, but the functor itself doesn't. That's
Yeah,
definitely a to do though. That's definitely
we
to do
should
problem.
probably yeah, we should probably change this.
Not now though.
Can we put comments in here? Is the question. We can, right?
Yes, of course. I just don't remember the token for it because there at some point I think it's percentage though, maybe.
the fact that GIMP uses Python is just obscene.
Why?
Yes, exactly, Lemus. Why?
No, 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 no. Why they use Python, I know. It's because they have very
Yeah, they probably
handy
run
libraries
like
for image manipulation.
yeah.
But
But like
this is
that's just
that's just gonna
obscene.
make your shit slow, man.
I think they use Python just for scripting though, no?
I don't know, like when you launch, it opens like a Python, right? As well, like a shell. But as Lemo said, it's probably the image trash.
Matplotlib libraries.
Well, not sure about matplotlib, but
No, it
uh,
is. Basically all the
Pillow.
Photoshop manipulations are Matplotlib. Oh, linear algebra,
Matplotlib is
right?
for plotting.
Yeah,
Yeah,
no, I said it wrong. You're right.
I think it's like NumPy.
NumPy, yeah, definitely NumPy.
Pillow. Pillow
Yeah,
is for image trash.
yeah, a bunch of transformations on matrices, essentially. Anyway, so put the to do, Marinho, and then let's just.
I don't see Python in here though.
Oh,
Maybe
you're
it's a
looking at the dependencies of GIMP.
Oh man, you went that far. Just thank you, Marinho.
Oh, but there's
Oh, this is
GTK
an older
plus.
version. There's
Oh,
this one.
Also, they added recently. That's
Yeah.
yeah, Python. There we go.
that
Python
is
3.
really. Oh man, we are really talking about enshittification right here.
Yeah, no, GIMP 2 doesn't depend on Python, but GIMP 3 does, apparently.
That's so silly.
Well, but like I said, you cannot deny the fact that NumPy is powerful, man. Unfortunately,
I don't think this is using NumPy though.
they probably are because image manipulation is essentially a bunch of linear algebra. So they probably
Which
are.
you. But GIMP is not implemented in Python, is my point.
Why
Oh,
not
they're
use
not
R
calling.
then?
That's also a good point. I don't know why R is an option for this.
Well, C is
Not
also an option.
show.
Most of this Python trash is built on top of C.
Is it really though? I never read NumPy's source code.
Yeah, see, Mason build system. This is
Well,
actually
not only
written in.
C, Fortran as well.
Yeah, this is written in C, I think.
Oh, so they are using Python for what?
Scripting.
Man, I don't know. I don't know why Python exists. To be honest, I do actually. I do.
I do
It's
know as well.
people wanted a replacement for Perl, and then they ended up with something worse than Perl. That's
Why
Python.
didn't they just use Lua? They could just have written text manipulation libraries for
I
it.
asked myself the same, Marinho. I asked myself the
But
same.
isn't that like a chronological thing? Like, is Lua that old?
Lua is from 2000. It's
I
from the
think
mid
it's
2000s. Python is older than Lua, I think.
Yeah, so there
oh,
we go.
is Python older than Lua? Is it though?
I have
Python
no
is from the
idea.
90s. Lua is from the early 2000s, I
I
think.
thought Lua was from the 90s as well, but I may be mistaken.
Well, well, Lua is better. That is for sure.
Well, it has based one indexing though.
Well, it's a Postgres also, then. So
Yeah,
what am
but
I
that
supposed
doesn't
to
mean
say?
anything. It's shit anyway.
I mean, they could have gone with Lisps or Scheme. They could have used freaking Emacs Lisp and it would have been better.
But it doesn't have tail calls.
Python
Well,
doesn't either, so you're not really
so
losing anything.
exactly.
Yeah, but you said
But you're
Emacs
getting better
Lisp.
semantics, at least that.
Okay, put the to do there, Marinho, for us to not forget to put the location later for functors.
Oh, by the way, I wrote an article about XML, right?
There's a typo there.
It was mostly a rant,
I
okay?
think I read that.
And I just sent that on like to Benet, right? And then he published that on Lobsters, like Hacker News.
As always.
Yes, and I kind of didn't want him to do that, but he did it. But anyway, then I was reading the comments, right? And then I was like, okay, like people there, like I prefer Lobsters because I think Hacker News is just trash discussions nowadays. But the level is higher. But still, I couldn't stop to think, man, nobody is actually attacking my point or adding up anything to the actual point, which
36,
is
Marinho.
it does not matter how XML looks, but the idea behind XML was abandoned. And that's the problem. Like all the other formats, they try to imitate manifestations of what come with applying XML.
Just a moment, Mageta. Marinho, you don't
Okay.
have to put a to do here. Just put the line 33 in a separate block with the unexpected closing curly brace instead of closing brackets.
This one,
Yeah,
module separator,
yeah.
right?
Wait. No,
But
this is
this is
module
writes the
separator. This
lim.
is not. Yeah, never mind. Go continue, Mageta.
Yeah, it was just that. Like I couldn't understand why like nobody there was talking about things that actually apply to the idea, just to the imperfections that are surrounding the idea. Like, oh, XPath, I used XPath and it's bad. Yeah, so what?
Is an idea
Like,
bad
okay,
because an implementation is bad?
exactly my point. Like, okay, XPath is bad, I agree. So what?
Yeah, but this is the same. This is the same discussion as always, man. People don't know how to separate an idea from
That's
its
what I think the
implementation.
problem is, yes.
No, yeah, but this is a
So
full
anyway,
foundational problem. Like this is very deep and very it appears everywhere,
Speaking
always.
it's a
of
problem of
that,
abstraction.
Mageta, what would you say is the central idea of XML that got abandoned?
Uh, well, I think it is a multitude of things that got abandoned, actually, not just one. Let me just find this Japanese font. Give me a second.
Okay.
I'm
And
surprised.
yeah,
How are we getting this
this
error
is
message though? Module separator. What is the module separator? Oh, column. Ident write the lim. Man, how are we getting this error message? Marinho?
I'm not sure actually.
Like we don't have a write the lim. We have a directive write the lim. So what the fuck?
Yeah, somehow, yeah, just somehow.
Okay, do the following. Put ident. Uh,
Oops.
And I found the perfect font, but I can't. Like, I need to log in websites to download it. It's like free, but you need to, well, log in on things to pay,
Search the name
right?
of the font
Zero.
on. Search for
Yeah,
the name of the font.
that's what I'm doing.
What is the font, by the way? What's the
Uh,
name?
Yopa Fude.
What a name.
Yeah, that's a bit weird in Portuguese. But anyway, it is a good font. It's like brush strokes, you see?
Yeah.
Ah, fancy.
Marinho, we need to make a clause that will conflict with something else. That's what we gotta do. We need to create a clause that represents that error on the right and see what the main here will say. Hey, this is conflicting with this thing. And then we go from there.
Okay, so this would be.
But how do you put a functor in there? That's kind of my thing. Like, how are we gonna know that you're missing, that you have a closing curly brace? What do we need to have on the stack, essentially, to detect that?
I guess we can do something like, I don't know, file. Uh, um, this is like. Let me
Tough,
search for
isn't
this
it?
actually, because I don't remember the name. Directive, okay. Like, directive writes the limb.
Unexpected, yeah, unexpected closing. Yeah, now we need to run the command. That man, I think we should make a just file or a make file for this because we're gonna keep forgetting it.
It's just a done build actually.
No, this is not regenerating the file. 1 and 31. So 31 is the one that you added. 1 is upper indent. Could you
That's incredible.
elaborate?
That's incredible actually.
Wait, let's check the definition of upper indent for a moment. Go to upper indent in the lexer. Let's see if we are by accident including curly braces.
In
Because
the
if we are,
lexer, right?
yeah, yeah. Uh, no, upper indent is. Wait.
Mm,
No, go back there. Go back there. Upper indent. Yeah, line 27, which is an upper letter, then a letter, underscore, and a digit. This is not including curly braces at all. So how in the freak is it identifying?
yeah, it's weird.
Yeah, but we don't know how to read this. How is line 1 and line 31 conflicting? Yeah,
All
you
right,
have
this
you
is
have to fix that. Yeah, comment the one down there.
the one down there.
Yeah, line
Why not
31.
this?
Because of that. You see? When it says that it's conflicting, it's because there are two ways. It's like ambiguous. It doesn't know how to do the thing. But what I don't understand is how is it understanding A as a directive right delim.
It shouldn't
That's
be.
that's what I don't understand. I don't understand that at all. Let's go to the
Okay, I
parser and
give
see
up.
how we are parsing variables, man. I think there must be something really fucked up in there.
Okay, give up on this font.
Mm,
Can you go please to the parser?
parser.
Yeah. Search for upper indent here. Yeah. Ah, wait a moment there. Okay, so any string is an upper indent apparently. Well, not any string, but that starts with a capital letter, right? That's how we are parsing it down there.
No, it's because these things are parameterized. They have a payload.
Yeah, no, but if you go back to where the upper indent is being used, yeah, anything will match. Aside, well, from the tokens that the lexer defines, right? But I'm assuming that there must be conflicting. So like the whatever you're using on the lexer to define, it's fucking it up.
If we put this here, does that change anything?
I'm also want to change the order.
It doesn't.
Yeah, I want to change the order of line 28. Like put line 28 as the first instead of declaration. Like let's try to parse a directive first and then a declaration.
This is unordered lemos, it doesn't matter.
This is unordered. Okay, so how do you explain that the variable upper indent is matching the curly braces?
I don't claim to be an expert on LR parsing.
No, 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 no. I didn't say that. I'm asking you if you have an idea, an hypothesis,
Mm, let me
on
think
how
for a
that would be
second.
possible.
That's
We
actually
need
a
the
good question.
we need the song of the X files here. Okay, I think I got a better font, to be honest.
They must begin with a predicate name, not a variable.
It's
Yeah, I have no
understanding that
idea.
closing curly braces is a variable, man. How is that a thing?
It's probably because it's impossible, according to the grammar, for this token to appear in that context. Although that doesn't make sense because Alexer doesn't know about the grammar.
Yeah, that's a very good point. What about line 24? Do you think it's possible that curly braces is involved in that range there? That would be kind of fucked up.
24?
Yeah.
No.
Like that's not a thing, right? I'm just imagining things.
Yeah, no, the curly brace is not in this range in ASCII.
Yeah, so 27 then should also work fine. Would you agree with that? Does the order matters for these rules for the lexer?
Does the order matter for these rules? Well, they're based on regular expressions, so they shouldn't, but they might.
Okay, grab all the delimiters and put it on the top.
Okay. Uh,
If that changes anything, then we have our answer.
nope.
They actually their position doesn't matter. Okay, so your hypothesis that it should not be able to detect that in that context, so it's following to one that could be, but that doesn't make sense, man. That's what I'm saying. Like, this doesn't make any sense, right?
Okay, what if we try copying this instead,
What do
but
you
we
mean?
add a directive write the limb here.
That's not our case up there, but sure. 31 and 22. 22 is ident left the limb. Man, what the fuck is going on? He's not is he it is conflicting left the limbs with directive the limbs for whatever reason. What
Mm,
the heck is going on?
maybe if parser.
Yeah, the parser must be fundamentally wrong if it's confusing those two things.
If we are parsing, not a declaration, a directive.
Holds functor dot holds functor directive. Where are we closing this shit?
What happens if we do this instead?
It's not a
Oh,
start
it's not a
symbol. It
start
must be a
symbol.
start symbol. And we only have a one start symbol for now, which is file.
That's sad.
Where are we closing the directive write the limb? Go to the parser. Where are we closing this shit?
In the body
Oh, 88.
88, 88. Yeah, here.
Where are we calling program fragment? Aside from 96.
Just these two places, the definition and the call site.
Man, what the fuck? What the fuck, man?
Put this later.
And this is why people write parsers by hand.
I have a funny experience about this, by the way.
Well, there's people also know better their library. So we are
That's
lacking both. So I
like I
don't
was doing
think.
something with a interviewer, and then it was like a basically logical replication of Postgres. And then he said, "Okay, what would you do there? Would you like try to implement yourself or use a library?" And I said, "Well, connecting to Postgres, there is a specification we could follow, but I think it's more error prone. It's one more thing to maintain. Uh, and depending on the scope, you might not want it, right? It's a burden." And then he said, "Well, I would agree with you, but if we want to do something, we're going to have to learn how to use the library." And I said, "Yeah." And then we just try to use the library, right, in Rust. And then he just said, "Okay, let's do this." And then we tried and we failed miserably because the library hides everything possible
Yeah,
for you
if
to
you
actually
yeah,
use the connection.
if you will
So
need to do use internals, you have to do it by yourself. Okay, I'm gonna finish the recording. It's already 2 hours.